What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 3.5, proving segment relationships. So still talking about our proofs, but now we're going to talk about the angle addition postulate, proof theorems about angles by using their properties of angle congruence, and then some right angles. Let's go ahead and get started. First one we're going to look at is the segment addition postulate. So it says if A, B, and C are collinear points and B is between A and C, I'm going to go ahead and pull up my drawing here, then we can conclude that AB plus BC is equal to the entire length of AC. We saw this in Unit 1 where we were solving for different areas of that, so that would be a postulate that we can use today. So example 1, we're going to try this one. It says, given that QT is congruent to RV and we want to prove that QR is congruent to TV, okay? So one of the first things that it says from statement 1 to statement 2 is we're going to be seeing that definition of congruence. So we notice that we are missing the lines on top of QT. So that means we're just saying this measurement of QT will be equal to the measurement of RV. And then it states this, QR plus RT is equal to QT, and then RT plus TV is equal to RV, okay? That's when we're going to pull into play our segment addition postulate. Okay. Next up, it says QR is equal to RT in the same way that RT is equal to TV. We just look like we either did some substitution or the transitive property. And remember, the transitive property and substitution can be interchangeable here. Then we're just left with QR is equal to TV. Well, we subtracted RT from both sides, so we'll say the subtraction property. And then finally, it looks like we're just adding in that line and the congruence symbol. So this will be the definition of congruence. Okay, let's go ahead and look at example 2. Now we're looking at CE is congruent to FE and ED is congruent to EG. I want to prove that CD is equal to FG. So the first statements we have, CE is congruent to FE, ED is congruent to EG, that's our given. Next up, we see that C is now equal to FE and ED is equal to EG. That is using the definition of congruence. And then we have CE is plus ED is equal to CD, and then FE plus EG is equal to FG. That's going to be our segment addition postulate. And then we have FE plus EG is now equal to CD. That is when we're going to use our substitution property because we know these are equivalent segments, so we can substitute FE plus EG and make it equivalent to CD here. So substitution. Then how we got from here to here is we substituted FG being equivalent to that FE plus EG. So again, substitution. And then we can use that definition of congruence for part 6. Okay. If you flip over your paper, example 3 is very similar, so you go ahead and take the time and try this one. So I'm going to have you pause the video here, try it on your own, and when you're ready to check it, go ahead and click play. All right, some of these can be done in 7 steps. I actually have mine going to 8 steps here. 7 is kind of like the standard of where you want to, but when we talked about you could go more if needed. So our given statements are as follows. Then I also just added in definition of congruence. So PQ is equal to TQ and UQ is equal to QS. So that'd be definition of congruence. Next up, we have example or statement 3. I can say that PQ plus QS is equal to PS, and this is where I added in 2 lines, so this is where I can keep it to 7. So if you added in 2 separate lines, you'd have to go to 8. TQ plus QU is equal to TU. So that's our angle, or sorry, our segment addition postulate. So now we can start some substitution. I can say that TQ plus QU is equal to PS using substitution. And then PQ plus QS is equal to TU, also using substitution. So that now I can say PS is equal to TU using the transitive or substitution property. And then final it out saying the segment PS is congruent to the segment TU. And that would be my definition of congruence. Okay, one more proof to try. This one's a little different given that R is the midpoint of QS and T is the midpoint of VS and QR is equal to VT. Prove that RS is equal to TS. Let's pause the video here, try this one on your own, and when you're ready to check it, go ahead and click play. All right, so I'm given my statements. R is the midpoint of QS, T is the midpoint of VS, QR is equal to VT. Now what I'm looking for is the definition of midpoint. So I can say that QR is equal to or congruent to segment RS, and VT is congruent to the segment of TS. And that's our definition of midpoint. Okay, next up I'm going to say that QR can now be equal to TS using the transitive property or substitution. And using that same concept, I'm going to switch around and say that RS can be congruent to VT, also using transitive property. These could actually have been done on the same line. Step 5, now I'm going to pull in and say that QS is congruent to VS, because again, I'm still using those transitive properties or substitution. So my final proof can be RS is congruent to TS using transitive or substitution. So sometimes our proof can just go using, once we've got that definition midpoint, we can interchange a lot of those things, okay? Thanks so much for tuning in for some math with Mullins about your segment addition postulate. Hopefully these examples helped you work through them, and then make sure to tune in for next time when we start talking about some angle relationships. Have a great day.